Okay, guys, let's talk about the normal distribution curve. Let's remember some things that we've talked about, and then we'll go through some problem solving with it, and then we'll be done. So this should be fairly, air quotes, quick, but I will not hurry, as they say. Just a reminder, whoop, wrong pen. That's not a good start. Right about here, we have the mean. Not a problem at all. If we go out this way, a smidge, or out this way, we have a standard deviation that is 1 unit long, or 1 standard deviation in either direction. This is also related to a z-score of 1 or a z-score of -1. Make that a little bit thicker. It's pretty thin. Okay, and by the way, this is 0 standard deviations away and a z-score of 0. If we go 2 standard deviations away, whatever that might be, that is a z-score of 2. That's why I put slashes through my z's and not slashes through my 2's. They look awfully similar. And we have a standard deviation of 1 or a z-score of -2. And by standard deviation of 1, I don't mean that. I mean we're 2 out. All right, and then we'll go one more out. Let me lengthen this a little bit, lengthen this line. There we go. 3 standard deviations, z-score of 3. 3 standard deviations below the mean, z-score of -3. Okay, so there's your quick view of z-scores, number of standard deviations, and remember the 68, 95, 99.7% rule. The 68% rule says that between the standard deviation that's 1 above and the standard deviation that's 1 below, all of those people, remember these are bar graphs, but there's so much data it's been smoothed out. This is 34% over here and 34% over here, or combined it's 68. That's the 68. You know, I should color code this a little bit better. It's like I have markers in class, kind of. 95. That's 2 standard deviations out in each direction. So I know that's 95% of all the data in a normal distribution, normal curve. My question is, just like the blue 34s, how much is in there? And how much is in there? Well, if we know that the entire amount from 2 to 2 standard deviations below and above is 95, and I know the blue section is 68, I can take the 68 part away from the 95 and get 27%. Actually, sorry, I'm getting a little carried away with my colors because I can. So that's 27% here and here. Or I should say 27% is split. It's split 2 ways. So it's, what is that, 13.5 in each one. All right, stop that and pause that, rewatch that again if you need to, because we're going to keep going out to this pink area. This is called the 68, 95, 99.7% rule, and that's 3 standard deviations below to 3 standard deviations above. But my question is, how much is in here and how much is in there? All right, well, if that purple section has 95%, and the, oh, I did that in the wrong order. if the pink section, whoa, if the pink section has 99.7% and the purple section has 95%, when you subtract away the purple, you have what's left over for the pink. And that is not a whole lot, okay? If my math is correct, that is about 4.7. Yeah, I was close. 4.7%. My dogs came downstairs, so they're very distracting. I apologize. Divide that by 2, and we have, what was that, 2.35? 2.35% here, and 2.35% over there. All right, so that is how it's all split up. And this was from last time, but I just wanted to start. I was going to start class with this, so I just wanted to keep going from there. All right, so the one piece that's missing is what is going on, will be really ridiculous with this color, out here and out here, to the left and to the right. Well, there's only 0.3 left because it's 99.7 is all the way out to the pink, from the middle going to the right and to the left. That's 99.7 of all of the data. So what's left over is just 0.3%. So if you think about that, it's just, oh gosh, will you be able to see that? 0.15% left going to the left over going to the right, and 0.15%. In other words, not very much at all. Okay, so that is your normal distribution curve that's split up into number of standard deviations and percents and all of those. Okay, now, if you focus in on z-scores for a second, whoop, these suckers right here. Guys, stop. Hey, stop. I'm making a video here. All right. If you look at these z-scores, we talked last time about how obviously we are not given exact z-scores every single time. We come up with approximations. We have z equals the data point minus the mean divided by the standard deviations. Well, there's a chart that helps you with that. And that looks like this. It's table 12.16. I was going to hand this to you in class, but we'll do it by video. Or maybe if I'm showing this to a class much later on, hey, I gave you this in class, let's look at this again. But you'll see all the z-scores on there. They're, broken down by tenths, sometimes by hundredths as you get closer to 0, but they're all there. There's 4 different columns. Okay, so we start right here. There's your mean. 0 is your z-score, and that's what you would think. It's the 50th percentile. So we got to kind of know and kind of figure out what's going on here. If you go 1 standard deviation out, now remember this is percentile. So if you go 1 standard deviation out, let's find 1 standard deviation. That's right here. The percentile gives you all of that, all of it. Remember, percentile is just a smidge different. It's a different way of looking at it. So what it's saying is from 1 standard deviation all the way back to left is 84.13%. That's the percent of people in that. And so this is all in with reference to percentile. Percentile is always positive, even though the z-score might be negative. So if we look at 2, right there, or I should say -2, we're looking right there, everything from there to the left. So that's 2.35 plus 0.15, I think that's 2.4. 2.28, it's close. Okay, so they get within a certain range. The 68, 95, 99.7 rule is not a precise rule. You can see my wife's anatomy up there. I didn't realize I was on one of her sheets. I'll have to erase this afterwards. But here's the chart that we are going to use. Okay? All right, so how are we going to use this? Well, let's look at a problem. Let's look at cholesterol levels. Let me get a color you can actually read. Cholesterol. 18 to 24 male. The mean cholesterol level is 178.1. For you nursing students out there, anyone going into medicine, that's milligrams per 100 milliliters. You don't need to know that. But cholesterol levels, that is the mean. Standard deviation is 40.7. 40.7 milligrams per 100 milliliters. Okay, so here's the question. What percent have less than 200? Less than a cholesterol level of 200. Okay, well, we cannot go straight to percent. We have to go to percentile. We then go to percent. And we got to figure out, based on the situation, what exactly is going on. Hold on, I got to get my dogs. I am not going to re-record this, guys. You guys need to get along, need to chill out, quit wrestling around. Like, play tug of war on that rope or something. Okay, I should show you guys some pictures of my dogs. Sometimes. All right, so what percent have less than 200? Well, I need to start with a z-score. Notice everything in here starts with a z-score. And we're also going to relate that to this stuff up here. Okay? So, my z-score for 200 is 200, the data point, minus the average, 178.1, divided by 40.7. You know this is a little too thick. You can tell I'm trying to get this out quick for you guys. All right, so 200 minus 178.1. Where in the heck is my calculator on this one? I've got an iPad I use at Warrensburg, and I've got this iPad, and I have no idea where the calculator is. This is so awkward. I know right where my, you guys are probably screaming, there's the calculator, there's the calculator. All right. Yeah, there it is. Oh, I haven't downloaded the calculator? Oh, geez, oh, crime. No, okay. Let me see if I can do this real quick. I'm on my Wi-Fi. Oh, it doesn't know my... I hope you guys are fast-forwarding through this. All right, here we go. All right. Hey, look, calculator. All right, so here we go. Load calculator, load. Oh, it's going to have commercials in it. That's just amazing. All right, so we have 200 minus 178.1. Is it 178.1? Yep, 178.1 equals divided by 40.7. It is 40.7. Yes, it is. Trust yourself, Brooks. Trust yourself. So 0.54, we'll call it. All right, so we have a z-score of 0.54. We're going to change this to a wavy equal sign. And now we're going to take our z-score of 0.54 and we're going to go looking up here. That one's pretty close. So this is the 70.88 percentile. What that means, if we normally distribute this thing, we've got 178.1. That's the mean. One standard deviation, a full standard deviation, is 178.1 plus 40.7. That is 218.8. All right, and it wants to know where 200 is. So 200, right there, use a different color, is 178, 200, and it's probably in there somewhere. So that makes sense. You're about a little over half of the way. That's z equals 0.54. And when it wants to know what percent will have less than 200, you find, it's 200, you find the z-score for that, and it's everything to the left, which is the definition of percentile. So in this case, that's 70.88% have less than 200. See how that works? Okay. So that, you might want to back that up. Sorry, you'd have to watch the calculator thing again, but you will understand how we start with a z-score, we find the percentile, which ends up being the percent that is less than the amount, and therefore the z-score that you find. The tricky part is, what about more than? And let's use the shaded. What about this? What if I said, what percent is more than 200? All right, think about that for a second. See this chart? It ain't going to tell you more than. It only tells you less than. But if you know the whole darn thing is 100%, and you know that below this line is 70.88, how do you figure out above? What percent is all of that? Well, that's 100% minus the part that's below. That will give you the more than. So this is key. Less than is just the percentile, changed to a percent. More than is 100% minus the percent from the percentile. All right, so what is that? 21.92. That looks right, 29.12%. Whoops, worst circle ever. Well, come on, there we go. There we go, that's much better. So 29.12% of males between the age of 18 and 24 with this normally distributed cholesterol scale have more than 29.12. I'm sorry, it's 29.12% have more than a cholesterol of 200. All right. So that's not bad. The third thing they can ask you is what percent is between healthy 140 and 180. What percent is between 140 and 180? All right, well, let's break this down again without going back to that complicated picture. Stuff going everywhere. That might be the worst normal distribution curve I've ever made, but that's okay. So that's 178.1. We'll pretend like that's 140, and we'll pretend like that's 180. The z-score here is 0. We don't know what that z-score is. We don't know what this z-score is, z of 140 and z of 180. We have to find them. Then, how do we figure out in the middle? How do we figure that out? Okay, listen carefully, back this up if you need to. This part, that percent, is equal to this percent minus this percent. Would you agree with that? This right here, that percent equals the red minus the green. I think you might be able to see it better if I had the red and I took away this much. If I took away that, what would I have left over? I'd have the blue. Red minus green equals blue. What do you think about that? Does that make sense? Back that up, listen to it again if you need to. Okay, now, the question then becomes, how do I get the red? Well, the red is just the percentile at z at 180. Whoops, sorry. The green is the percentile at z 140. I find the percentile or the percentage of the red and I take away the percentage of the green, I will have that percent right there. Okay, it's kind of a part plus part equals whole, or the whole thing, the red, minus the green part gives you the other part. All right, so let's get to work. Z of 180, that's all that red, equals 180 minus 178.1 over 40.7. That's going to be approximately, okay, I'd love a commercial right now. That'd be great. No. All right, I can't remember the numbers. Can I remember? Yeah, 180 minus 178.1 equals, divided by 44. 180. Dogs. Guys, Dave, stop. Divided by 40.7. 0.0, I'm going to call it 0.05. I'm making the call. 0.05. Dave, Duke, stop. Chill. All right, so now I'm going to look up here. 0.05, 0.05. That's my z-score. 0.05, 0.05. There we go. 51.99%. Percentile, which is also percent. Okay, that's not bad. Let's do the green. Z of 140 equals 140 minus 178.1 over 40.7. So that equals 140 minus 178.1 equals negative 38.1 divided by 40.7. Negative 0.94. Negative 0.94. Negative 0.94. Negative 0.90. Negative 0.95. We're just estimating here. So 17.11. Percent, because it's everything to the left. So now my blue, this right here, is going to be 51.99 minus 17.11. .88% would be the percentage of 18 to 24-year-old males that have a cholesterol between 140 and 180. Super healthy. All right, see how that works? All right, so if you want your answer less than, that's just your percentile. Figure out your z-score, look at your chart, and that's just your z-score. More than, you got to take 100 minus your percentile, because that represents everything above that z-score. Between, you've got a part plus the other part equals the whole, or the way we're choosing to look at it is you have the whole thing minus this part equals what you have left over. It's a simple mathematical concept with a whole bunch of numbers attached to it, but the general concept is that. Okay. That combined, what I just talked about, combined with some distractions from my dogs, combined with me having to download a calculator in front of you, is what you need to know, for the most part, for this section. You can also watch some of the videos to fill in some of the details. I'm going to go over one more example, but you can get out of here because I've done everything that we need to do. But I'm going to show one more example if you're interested in hanging with me. Okay? Oh my gosh, you stayed. That's amazing. All right. Let's look at this. Let's think, I've got two different examples here. You guys want to do cell phones, or you want to do self-employed American hours per, I'm getting bored just talking about the second one already. Let's do cell phones. Okay, so now this was in 2016. Cell phone cost. The mean per month for cell phone cost back in 2016 was $62 per month, with a standard deviation of $18 per month. So I got some questions. What percent paid less than $90? Okay, so looking at the quick normal distribution curve, let's say $90 is right there. That's all these people. So I need to find the z-score associated with 90, and then I'll find the percentile, and that is the percent based off the percentile. Piece of cake. So 90 minus 62 divided by 18 will give me my z-score. 90 minus 62 divided by 18. 1.56. Okay, don't get dizzy. Here we go. 1.56, 1.56. 1.5 and 1.6. So I'm going to use 1.6 because 1.56 is closer to 1.6. So 94.52. That is 94.52 percentile, but that also means the percent. So we're good. Okay, how about more than? What's the percent more than, I don't know, let's say $70. So I need to find z of 70, and I need to take 100 minus whatever the percentile is in there. Because remember here, we're going to find z of 70, and I want to know this. So I got to take all 100. That is the worst brace I've ever made, or bracket, I should say. That's 100%. So I'm going to take 100% minus this stuff. Would give me the blue stuff. All right, so let's go back to find the percentile. Z of 70 equals 70 minus 62 over 18. 70 minus 62 divided by 18. 0.44. All right, 0.44, 0.44. I bet you there's a 0.45. 0.45, 67.36. Whoops, wrong thing. 67.36. Now that, the color coding's kind of throwing you off. That's this stuff. That's everything below. So I need to take 100 minus 67.36 to get that stuff. All right, so 4, 6, 2, 3. 32.64% is above, so about a third paid above $70 back in 2016. And you know what's coming next. Let's go between $60 and $75. So, if that's 60 and that's 75, I want to know this. So I'm going to find the percentile for 75. I'm going to find the percentile of 60. I'm going to take this thing minus this thing, and it'll leave me with this thing. Oops, I've gone too far. All right, so let's find z of 75. I don't know why I put percent there. $75. So z of 75, that's this top line right here, and all of this. Okay. All right, z of 75 equals 75 minus 62 over, I forgot what it was, 18. 75 minus 62 divided by 14. So 0.93. I bet you there's a 0.95. Sorry, 0.95 right there. 82.89. 82.89%. That's all of this. But now I'm going to take away this. So I'm going to find Z of 60, which is 60 minus 62 over 18, which is negative 2 over 18. 60 minus 62 divided by 18, negative 0.11. I'm going to add it right there. All right, negative 0.11, negative 0.11. Oh, that's pretty close right there. 46.02. That's this much. So that middle amount right there, all of that is the 82.89, which is this, minus 46.02, which is that. And that gives you what's left over, which is that. 7.863. 36.87%. There you go. All right, guys. Good luck. This combined with watching some videos, if you get confused, should get you through 12.5. I'll see you guys next class.